about the flow control in TCP. Flow control means what? That sender, receiver. Sender cannot send too fast, faster than how much the receiver can handle, because by doing so, you are going to overwhelm, the sender is going to overwhelm the receiver with too much of data than how much it can handle. So there has to be some kind of a synchrony between the sender and the receiver. The rates at which the sender is sending should be such that the receiver should be able to handle. That is called flow control. So in other words, the flow control mechanism balances the rate a producer creates data with the rate a consumer can use the data. Okay? So flow control basically works on the principle of feedbacks. So let us try to understand how flow control feedback works in a sender receiver kind of scenario. Let us say that you have a sender and let us say that you have a receiver. The sender acts as a producer, the receiver acts as a consumer. The producer, basically the sender application keeps on generating the data which are going to be pushed to the transport layer. Okay, so this transport layer consumer is going to get the data from the application layer producer. Then this application layer producer, okay, it's going to push the segments out and send them to the receiver. So this receiver transport layer, it will again send the messages to the consumer application layer, that means the receiver application layer. Okay, then based on this thing, basically if it is found that the messages are being received at a faster rate, then there is a flow control feedback that is going to be fed back to the transport layer of the sender, and then this transport layer of the sender sends a flow control feedback to the application layer of the sender. So essentially, if you are producing data faster than how much I can handle, I will send you an indication towards it so that you can slow down. That's all, nothing else. Okay. Any question? If not, we need to understand how this sliding window mechanism is going to be used in how the sliding window mechanism is going to be used in TCP flow control. So in TCP flow control, you are going to have one window being maintained at the sender side, which is called the send window, and another one which is called the receive window. Okay, which is the receive window. Now, the send window in TCP is similar to the selective repeat protocol that you have learned before. Exactly the same thing with certain changes. Actually, this flow control mechanism in TCP is a combination largely of the selective repeat protocol and the go back N protocol, both of which you know by now very well because you got in your exams. So the selective repeat protocol as well as the go back N protocol are going to be used in order to handle the flow control in TCP as well. So, but there are some differences. The first difference is the nature of the entities that are related to the window. The window size in selective repeat is the number of packets, but the window size in TCP is the number of bytes. Doesn't matter. Concept is same. There you called it packets, here you called it bytes. Not call. Actually, the unit that is handled entity that is handled is different. Here you are handling bytes. Achha. Although the actual transmission in TCP occurs segment by segment, the variables that control the window are expressed in bytes. Now the second difference is that in some cases in TCP, it can store the data received from the process and send them later. But we assume that the sending TCP is capable of sending the segments of data as soon as it receives from its process. The third one is how the timers are used in TCP. So in SR protocol, there were several timers that were used for each packet sent, but the TCP protocol uses only one timer. These are the three main points of difference between selective repeat and the the TCP protocol at the sender end. But otherwise, basically, it looks very similar. So, if you look at the send window, let us say that it is like this, that this is your first outstanding byte, SF. SF is the first outstanding byte. Okay. Then SN is the next byte to send. Okay. So you see that 201 to 260 is the outstanding bytes that are sent but not yet acknowledged. Okay. Till 200, whatever you have, these bytes that were sent were also acknowledged. So you keep them out from your window. In your window, whatever has been acknowledged, you remove it out, purge it out of the window. So this is your outstanding bytes that are not yet acknowledged. Then you have the bytes that can be sent. That can be sent. It has not been sent. It can be sent. Okay. So this is basically the bytes that have been sent but not yet acknowledged. Whereas then you have the bytes that can be sent, and then you have the bytes that cannot be sent until the right edge moves to the right. Right edge. When will the right edge move to the right? When will it move? When here the corresponding byte has been acknowledged. When you get that byte acknowledged, this is going to shift rightwards. Okay. So this is the scenario for the send window. For the receive window, the difference between TCP and SR, that means selective repeat, is that the TCP allows the receiving process to pull data at its own pace. That means that part of the allocated buffer at the receiver may be occupied by bytes that have been received and acknowledged, but are waiting to be pulled by the receiving process. That means the application has not yet pulled it here. The receive window size is then always smaller than or equal to the buffer size. So the receive window size basically will determine the number of bytes that the receive window can accept from the sender before being overwhelmed. In other words, the receive window size, which is R window, I told you earlier, is going to be how much? So you see the receive window is, see what happens when the bytes are received at the receiver. These are first going to be buffered, and then the application is going to pull them out from the buffer. Now, how much will be the receive window size? It will be the buffer size minus how much has already been sent. Oh, sorry, number of bytes waiting to be pulled. That's right. So how much it has been sent. So buffer size minus this one is going to dictate the receive window size. The second difference is the way the acknowledgements are used in the TCP protocol. In the acknowledgement in the SR basically is selective. SR is selective, right? So which will define the uncorrupted packets that have been received. The major acknowledgement mechanism in TCP is a cumulative acknowledgement announcing the next expected byte to receive. Right? So here basically it is similar to go back in protocol, which says that so this was the last byte that I was expecting. Okay. So go back in. and so all the basically all the segments are going to be resent afterwards. So at the receive window end, the scenario is like this, that 201 to 260 is going to be your bytes that are received and acknowledged, but the corresponding application has not yet used them. Till 200 are basically the bytes that have already been pulled by the process, and then you have 261 to 300 are the bytes that can be received from the sender. That means the receive window size, and 301 onwards bytes that cannot be received from the sender. So how does the opening and closing of the receive window take place? Okay, so there is a left wall and there is a right wall. Whenever an acknowledgement is received, right? So these walls are basically pushed to accommodate more. So that means that the moment something has been received and acknowledged, you shift your left wall and your right wall. Now, how this left wall and the right wall are going to shrink? The exact mechanisms I'm not going to go through exactly, but basically, this is quite understandable, very similar to what we had done with flow control earlier. So you please go through it, and if you still have any doubt, you can ask me. But what I would like to show you is this thing at the client side and the server side, how this flow control is invoked. So first it starts with the first segment 1. It is called the sync segment. Sync segment means synchronization. That means that the client says that I want to start the communication. So this sync segment contains the sequence number. So it advertises that this is the sequence number equal to 100, and this sync segment is sent to the server. The server, it is going to send the second segment back in this manner. It's going to send an acknowledgement for the SYN, and also it is going to send a SYN in the other direction. So that means the previous acknowledgement plus the current SYN in the other direction are both going to be added together, clubbed together and sent. With these three parameters, sequence number, which is 1000 in this case, acknowledgement number 101. So what does acknowledgement number 101 means? That I have received till 100. The next segment that I am expecting is 101. So, and the receive window size also it is going to advertise at this stage. So through this advertisement now, this fellow, it knows that the size of the receive window is 800, so it will adjust its own size accordingly. So then the client is going to send the third segment back, which is going to be just an ACK. This ACK basically contains the acknowledgement number, which is going to be the sequence number that it has received, which is 1000 plus 1, which means that now it is expecting 1001, that one. Okay, so the segment that it is expecting from that direction is 1001. But mind you that in this particular example, this scenario basically is not illustrated any further. So only the client to server sending of the data packets is shown. Now the fourth one is going to be sequence number 101. So now this handshaking has happened. Now the actual data transfer is going to take place. So now the data transfer sequence number 101, that means it is saying that, it is sending the segment with the sequence number 101. The data is going to be 200 bytes. So if the data is 200 bytes on receiving over here, now this receive window size is going to shrink from 800 to 600. 800 minus 200 will be 600. It is going to be like this, 200 bytes is received. So now the window is going to shrink and it is going to close. Now, fifth segment that will be transmitted is the acknowledgement of this particular segment that is received. This acknowledgement is going to be 301. Why 301? Because 101 plus 200 is 301. So that means that through this act, the server is telling the client that now I am expecting the next segment, which is 301. So like this, actually this process continues further. Cumulative acknowledgement is something that you need to understand, because this has similarity to the go back N protocol that we had studied earlier. TCP was originally designed to acknowledge receipts of segments cumulatively. So it gives only the positive cumulative acknowledgement, which means that no feedback is provided for those segments which were discarded, which were lost, or which were duplicate. Okay, so this positive cumulative acknowledgement mechanism is used. Selective acknowledgement. There is another mechanism which is called selective acknowledgement, SAC, S-ACK, selective ACK. But it does not replace the ordinary ACK, but reports additional information to the sender. A SAC basically reports a block of bytes that is out of order and also a block of bytes that is duplicated. Okay, so selectively it will tell that, you know, this is the duplicate set of bytes that I have received. Selectively it will inform. Okay. Now retransmission after RTO. The sending TCP basically maintains one retransmission timeout for each connection. When the timer matures, that means it times out, TCP will resend the segment in the front of the queue and restart the timer. The value of the RTO is going to change dynamically, and it will be updated based on the RTT of segments. Okay. After 3 duplicate acknowledgements, what is going to happen with the retransmission? If 3 duplicate acknowledgements arrive for a particular segment, the next segment is retransmitted without waiting for the timer, because it is construed that the 3 duplicate acknowledgements means that there is some problem and the next segment will be transmitted without waiting for the timeout. So here is the so you see that the sender and the receiver, the corresponding FSM is shown. At the sender side, you have 2 states. One is the ready state, the other one is the blocking state. So, you know, so the corresponding state transitions are also shown over here. So if you understand all these different transitions, you will be able to understand basically how the sender side window is going to change over time. Same goes for receiver side, but in the receiver side, we have only one state, which is the ready state. Okay. So the corresponding transitions are also given over here. I mean, basically, you know, so you need to, why I'm not going through each of them is that you need to really, you know, keep these in mind, right? So there is more of remembering the different transitions than of actually understanding is very easy. There is not much, but you really need to keep them in mind. This is a little difficult, but again, you know, you need to do it. So let us now try to understand beyond these state transitions what actually happens. Normally in TCP, when there is no congestion, etc., this is how the communication between the sender and the receiver is going to take place. So you see that first segment sent with a sequence number 1201 to 1400 and acknowledgement 4001. So here here we look at the sequence number here and the acknowledgement number here. So the sequence number over here is different. This is basically what this fellow is going to send, right? So the sequence number here and the sequence number in the other direction are independent. But what is the acknowledgement over here that is piggybacked with the corresponding segment that is transmitted? This acknowledgement over here is 1401. What is 1401 mean? That this receiver is telling the sender that I have received till 1400. Now the next byte that I am expecting is 1401. So this fellow, he receives it, starts his timer, okay, and then it times out. After 500 yes, after 500 millisecond, it times out. When it times out, then this fellow is going to send the acknowledgement 5001. So why 5001? Because it has received 5000, and then it says that I'm expecting to receive the next byte, which is 5001. So 5001 to 6000 is going to be sent, because 1000 bytes at a time, and the acknowledgement is going to be 1401. Now you see that here the acknowledgement was 1401, again the 1401, and again by repeating the same process, 3 acknowledgements with the same 3 duplicate acknowledgements, 1401. Okay. If there is a lost segment, like this, what happens? So if there is a lost segment, another segment that is going to be sent, let us say that this segment containing the bytes 701 to 800 is going to be lost. Then let us say that another one is going to be sent 801 to 900. But once this fellow receives it, it receives it out of order. So what it is going to do? It is going to store in its buffer, and it is going to inform the sender that I am still expecting 701. So this 701 is received over here. The sender will resend 701 to 800, which will be acknowledged subsequently. This is how the lost segments are handled. Clear? Any question on this part? So whenever there is an out of order receipt, 2 things it will do. It will buffer. It will not discard. It will buffer, and it will explicitly inform the segment that it is expecting. Next. This is fast retransmission. Here also you see very similar. So you see that 201 to 300 at 301, 301 to 400 lost. Then let us say that this one is sent 401 to 500. You get an acknowledgement 301. So this is your first duplicate. Again you send 501 to 600. You keep on doing it, right? But you get another acknowledgement with the same duplicate acknowledgement. Again 301, 301, again 301. Then 601 to 700. Get again the same acknowledgement. Third duplicate. First duplicate 301. Second duplicate 301. Third duplicate 301. Then the rule says that if you have a scenario where there are 3 duplicates, you first retransmit very soon, quickly. You retransmit that one 301 to 400, because this is what it is expecting. 301 to 400. Now once you do it, everything will be in order. What happens if there is a delayed segment? TCP basically uses the services of IP, which is a connectionless protocol. Now each IP segment basically encapsulates a TCP segment which may reach the final destination through a different path, because IP works independently, right? So through different paths, basically IP will send the TCP segments, right? So some of these TCP segments may be delayed, isn't it? Because IP is providing the services to TCP. So some of these will go through different parts, so some of these TCP segments will be delayed. So these delayed segments sometimes may time out and be resent. If the delayed segment arrives after it has been resent, it is considered a duplicate segment and discarded. Very soon, another 2 or 3 minutes, we'll finish off. Don't worry. Last, not last, another one, automatically corrected lost segment. So if the TCP acknowledgement mechanism, in the TCP, a lost acknowledgement may not even be noticed by the source TCP. Okay. So for this, TCP uses the cumulative acknowledgement. So by this, we can say that the next acknowledgement automatically corrects the loss of the previous acknowledgement. How? That means, so you have the RTO timer which starts, okay. So segment 501 to, sorry, bytes 501 to 600, 601 to 700, acknowledgement 701 lost, then sequence number 701 to 800, automatically, you know, it keeps on sending it, right? So 701 to 800, 801 to 800, but then this guy gives an acknowledgement 901, because this one 701 was lost and the server doesn't know. So the next acknowledgement it is going to do is for this one 901. By doing it, automatically the lost segment, lost acknowledgement has been taken care of. Here is a scenario you go through. I will not tell you again. So here basically the lost acknowledgement is corrected by sending a segment. Okay. So this one, and that's all. So these are the different mechanisms for flow control in TCP. So congestion control, flow control, very important in TCP apart from others. But remember that you should practice very, very well these two things, because you might definitely, you know, so in general, I'm not talking about the question papers that you are going to encounter, but in general, you know, so in TCP, from TCP, flow control, congestion control, expect questions. Okay, you should understand this very well. Some of these, there was concept that was involved. Some of the others, basically, you have to simply remember, like the timers, the FSM, etc. Right? You have to understand and remember, of course. Okay, that's all. Thank you.